Okay. So I've announced yesterday, I would like to test all the volume plugins we have in Kubernetes. And we can't test them because the test infrastructure doesn't have installed all the utilities we need for testing, like iSCSI, RBD, and whatever. So for past 2 or maybe 2 years or maybe longer, I've tried to containerize all the mount utilities. The mount utilities for this project is everything that volume plugins execute. That means anything that is needed to provision or delete a volume on master, attach, detach volume, again, execute it on master, and mount and unmount something. In reality, it means we need to make file systems, check file systems, attach iSCSI volumes. Sometimes we trigger UDEF. We talk to RBD. Sometimes we insert modules. We call flex drivers and other things. And last but not least, we do mount. But the mount is like top of the iceberg. We need all the utilities here to work with volume plugins. So I have a proposal open since April to run all these utilities you saw in containers, in pods. The primary goal is to run end-to-end test. As a side quest, I have enablement of limited distros like Google's GCI, CoreOS, Red Hat Atomic Host that don't want to ship these tools either. So we could run Kubernetes there and still use iSCSI, use Ceph, and everything. So the proposal is proposing that there is a daemon set running in Kubernetes that will put container on every node, and the container will have all these utilities inside. So it will be basically some distro, I don't know, CentOS, with installed iSCSI packages, and that's it, nothing else. You can run as many daemon sets as you want, or you can have one giant daemon set that will have all the utilities that you need. It's quite open. And this daemon set will register itself into Kubernetes. And that's the problem. How Kubernetes will know that this pod on this node is serving utilities for that particular plugin. On kubelet side, on the node, it's manageable. After many discussions, the current idea is to put a file into Magic directory, warlib kubelet, plugin containers, plugin name. And the file will contain a simple JSON with coordinates of the pod that is running on the node. So kubelet on the node, if it's looking for a container that serves cluster, it will look into warlib kubelet plugin containers cluster.json. It will see namespace and pod name of the pod that's serving on that node cluster. And anytime kubelet wants to, anytime volume plugin wants to execute something, it will use the volume host interface we have in kubelet. And this interface will lead to Docker exec inside the container. Very simple, and it works. This registration of containers is kind of ugly. I don't like it. People don't like it. And in 1.8, Kubernetes added dynamic registration of plugins for GPUs. That means that kubelet exposes Unix socket that listens for messages, gRPC messages, and these messages can be used to register GPU driver. And in future, this could be extended to register something else, for example, CSI plugins, and also these containerized mount utilities. So this is kubelet. That is easy. We can mount and unmount stuff. What's the problem is...
So
Yeah.
Before we go too deep, so that daemon set, what is it running? Is it just a sleep infinite loop?
Yeah, it should. It can run sleep. Some.
I mean, until somebody runs Docker exec.
Yeah, it just.
The daemon set is just around.
Yeah, it's just around. Some volume plugins run fuse daemons inside the container. That means it should run some kind of init that will kill the orphans, but it's just sitting there doing nothing. And everything what happens is just this Docker exec something.
Is in the CRI. What's the status there?
Well,
is using Docker exec, right?
No, it's not using, of course, Docker exec. It's using directly CRI. Docker exec is here because everybody understands a Docker exec, but inside it uses CRI exec sync method.
So everything you have said, it applies to in-tree volume plugins.
Yes.
And in 1.8, just like you said about the registration for GPU thingies, something happened on the FlexWall side.
Yes, I will forget.
Could dynamically know about new plugins by just dropping files.
Yes, I will talk about it later. So this is kubelet. Kubelet is simple. Put the file somewhere on the host, and kubelet will execute the things in the right container. Simple. Container manager is much harder because you can't run things on masters usually. That means that the control manager must find these pods with mount utilities and execute something inside them. The execution part, it's manageable. We have kubectl exec, and we have API for that. But finding the containers is hard. And I don't have any good answer for that. And initially, I don't want to implement this interface in controller manager because it affects only Ceph RBD provisioning. And I can live without testing Ceph RBD provisioning. And if it affects Flex. So in the first implementation, I won't touch it. And maybe it's not necessary at all. Because we have this dynamic registration of flex volumes in 1.8. It works quite similar to this, that a flex volume vendor distributes a daemon set and means runs it. The daemon set puts a pod on every node, and this pod will put a flex volume driver into the right directory, the user lib exec, Kubernetes something, I don't remember the path. And Kubernetes watches this directory, and whenever new driver appears there, it loads it and initializes it. Again, this works only on nodes, on kubelet. So if you can't register a flex volume driver with attach-detach capabilities this way. I haven't heard anybody complaining about that.
So the same reasons why we want to put these mount utilities inside containers is the same reason Flex today doesn't work on platforms like Atomic, because trying to put binaries back there is a problem.
Sat, in his CSI proposal, he has sort of externalized the attachment from the master. It can run anywhere. So it could be either extended to support also Flex, or when CSI is there, everybody moves to CSI and we don't need Flex attach-detach at all. So that would be my roadmap.
Yeah, this is Chakri on the phone.
I think we will have internal volume plugins for quite a long time, and I want to test them. That's the primary driver for me. And my idea is that we will add new features to the internal volume plugins, like snapshots, like resize, like I don't know what. And this will come only slowly to CSI. When they get stable, tested somehow, and we have API for them in Kubernetes, and we know it works, then we will move it to CSI.
You're talking about containerizing the mount utilities, and for the distributions like Atomic, like it just makes sense to have include whatever utilities they need.
Kubelet is not containerized in most deployments.
Kubelet is containerized in OpenShift, but the thing is, if you run Gluster, we have them installed there, but the thing is, you have a kubelet container with everything inside, but if you run Gluster, it runs fuse daemons inside the container. And if you restart kubelet, you restart the container and you kill all the mounts. And that's not what we want. So we must run the fuse daemon somewhere else, and that's this container.
Is it possible by doing this, though, it changes the behavior?
Measuring performance is one thing. That's probably not going to work because you get different numbers, but all the volume plugins now, I have changed them in a way that they don't call os.exec. They call some interface, and kubelet provides the right interface to them. So the interface can lead to the operating system, to the host, or it can lead to these containers. So the volume plugin codes is all the same in both cases. If you run them on the host or inside the containers, the volume plugins are the same. So I'm pretty sure I'm testing the right thing. I just changed where the exec happens.
This is primarily targeted.
Well, I just had a follow-up question, right? So, like, as far as how much CSI addresses is, right? Like, if CSI plugin is still wanting to use iSCSI for attach, detach, like the iSCSI driver, and if it's not a OS stuff, this to be able to pull the iSCSI container down, propagate around.
CSI works in a way that kubelet talks to the CSI plugin or driver, whatever it is, using gRPC. Attach it, mount it, provision it. This is direct gRPC call. How the CSI driver does it, what it uses, if it uses iSCSI Adama, and when it runs it, it's outside of Kubernetes control, and we don't care.
But you're saying CSI plugins should be containerized.
Yeah, but that's
not just
Well, the spec doesn't. I think the design says it's still optional. You hope so for certain plugins, right?
So
It's up to the storage provider who writes the plugin to decide.
So if you look at the storage provider's plight in the CSI world, of course they'll ship a container.
Yeah.
But this container, if it has to ship whatever it has, iSCSI ADM or MKFS, they are now into a exploding compatibility matrix because these are all client utilities like MKFS, now iSCSI ADM. They talk to daemons and stuff in the kernel on the host.
yes.
And so they now have to say, I'm shipping iSCSI ADM in my container or sub-container or whatever, but how do I make sure that client can actually talk to the things that are running on the host? And so I was just trying to make the point that the mount container is even more critical in the CSI
I'll give you an example. Yeah, sorry to interrupt. Like RBD, you can't take the RBD utility across the you're going to have an exploding matrix.
iSCSI ADM is known to fail. It is so build sensitive that it has to be from the same build as the iSCSI daemon, which already runs. So we've gone through this problem where we shipped iSCSI ADM in our driver. And
Can't you run iSCSI inside the container?
You can, but the customer won't allow you to do that because how many iSCSI daemons can you have on a host?
Just one.
If there's what?
Just one.
No, if Scale.io driver is installed and NetApp driver is installed and they ship their own iSCSI daemons.
You can have more than one.
It's going to like this. When you talk about getting specific about storage platforms, like the tools put in that container, you can't just generalize and say it's RBD. It's going to be like what version, and maybe not specifically for RBD, but I guarantee you're going to run into vendors wanting to ship versions to support their platform, which falls into the CSI.
So if there is,
the vendor's got to really supply what that all is. Now you're kind of saying, hey, I want you guys to create two separate. Create one that's your mount, and then we'll do one separately for CSI.
Well, there are creative options. For example, if the image is there and the guideline is to say run a daemon container that does some prep work and stuff, storage vendors get options like I could derive from this mount container image because it's something working with Kubernetes.
Yeah.
I'm not trying to design it here.
I don't think what Jan is suggesting is a single container for all mounts. That might be where the confusion is.
Is that what you were suggesting?
No.
Okay.
I would like to.
So to clarify, I think what Jan is proposing is. Oh, sorry. So I don't think Jan is proposing one container that contains all the mount utilities. His proposal is, actually, I'll let him speak for himself. Go ahead.
Oh.
Do you want to clarify?
I personally going to ship is images for every volume plugin that will run on E2E. That means on GCI probably. I will test it and I will check it works.
So separate images for each utility.
Each volume plugin for iSCSI, I will have image with iSCSI and iSCSI ADM. For RBD, I will have image with RBD. And that's it.
So let's just play that thing. So iSCSI ADM, the driver might also support mount. Just having iSCSI ADM for the iSCSI internal plugin might not be enough.
Oh yeah, of course. It will have mount. It will have makefs for X4, XFS, and all these tiny things. But these are usually in the base image of any distro.
One global have it all image. We go plugin by plugin. And
Yeah.
So there'll be duplication across these images, but
I don't care.
Is it an optional thing? Like if you want volume prep plugins today to operate as they operate, what are they going to have?
It's optional. If you have all the utilities on the host, you don't run any daemon set, everything will work as it is right now. If you deploy the daemon set, then Kubernetes is going to use the daemon set. If you deploy it and it is registered. If nothing is registered, everything runs on the host.
I totally agree. We need a way of testing plugins. I think Clint and I are totally on board with that.
And okay, I will test it in the E2E. We will see what works, what doesn't work. And in CSI, you have something to start with.
So regarding kernel dependencies, you assume all the kernel modules are already installed on the host, and you just, is that good for CoreOS or Atomic? Or
I checked CoreOS, I checked Atomic, I checked GCI, all the volume plugin, all the kernel modules are there already, including Ceph, including Cluster, including Fuse. Everything is already there.
Okay. Now, I've talked to a company. They seem to have the technology to inject the kernel module from a container, but I don't know how they do it. And
well, you just call mode probe in the container, and it will do.
But imagine you have now multiple of these containers. They all, let's say, want to have access to the iSCSI module. Let's say NetApp iSCSI driver and EMC iSCSI driver. They all want to access the same module, or they want different versions of the same module. So that it can get hairy.
Yeah, it's kind of hairy for vendors.
Before we get too far in this, I'm kind of stuck behind it. All right, we've done this. We've been working on this for like 3 years now, and there's a lot of technical details. I think that we're not kind of giving up on the feature part of it. It's really now just for end-to-end tests. Right? We're not trying to get this to work on every, or like trying to make it, a feature that is production ready for stuff. We just want tests to work.
Can you clarify that?
Going enablement.
Clarify like what you mean.
Clarify the microphone.
Is there a microphone in the mic?
There's one right there.
When you say, I guess I'll clarify, was like when you say this, like, you're talking about containerization of defining utilities, like what's
Yeah, the whole
Yeah.
containerization of the client utilities. It's like all of this is just for testing. Like it's not meant to be like a production thing. It's not meant to, span all the different operating systems. Like there's a ton of technical wormholes that we could go down here. And we've been down them for 3 years. And frankly, that's what stopped us from getting the feature in, to the point where like we're, a hair away from giving up on it, but we need it for the end-to-end tests. So it's easy to derail because we've been derailing on this thing for 3 years now. I want to make it clear that we're just trying to do this for the testing. It's just for tests. Like it's not for production systems. It's not for,
But
driver rollout.
to Jan's point, that the same thing, exploring this in our test framework might give us might inform us on how we can proceed for the bigger picture.
Right. There could be bigger picture ramifications from it further down the line, but this isn't the time that we want to, bring that forward as part of the design. We want to keep this very narrowly focused. So, because it will derail quickly if we start rat holing on it, right? Like there's just too many cheesy rat holes here.
So, so I find myself arguing exactly the opposite of what Brad is proposing, that currently where we are with FlexWall, and I'd like to go around the room to see how much interest there is for actual making FlexWall work in a supportable way for customers. That's one problem. But with FlexWall and attachable, detachable plugins, and with recent container platforms like Atomic becoming prevalent, and with CSI coming in, this is no longer an internal plugin testing only. The solution fits everywhere, and it's more critical that we.
You're right, but if we try to solve all of that right now, we won't get.
No, we can break it down into phases, but I would like to take the equation. Like I would like to request broadening your scope to say this is not just for testing. This is not just for internal plugins, because it makes life better for the Kubernetes testing if we just go this route. But it makes, because as a Flex Volume or as a CSI author, I don't get, there's a wall, right? I don't get this awesomeness if we.
No, that's right.
Well,
So I'm all for reducing scope and saying, let's take this baby steps and only do this for this, but keep in mind that this might be useful in a production deployment.
It will be, but we won't get the first phase done if we talk about all the rest of it. We've tried that. Like we just tried it. We never get past.
And to be honest, there is no awesomeness. There is just Docker exec inside the containers. And in CSI, you will have gRPC. That's all the difference.
No, the problem of the comment that you made about atomic host, that affects FlexWall and CSI much more seriously than your internal plugins.
So I think we're all in agreement. I think the only difference is you want to make sure that there's more follow through after this step. And I think there's other people who just want to make sure the first step happens. So I think, am I correct in the perception there? I'm sorry, I got to run away for a quick second, but yeah, so
Hi, I would like to.
that's it. So let's agree that this is the first step, and then let's let this step be completed, and then make sure that we then take, the next steps to make sure it integrates with Flex and CSI.
I feel like if this is for testing, I didn't catch that like in the intro. That was the intention. That this is to make testing successful, and that makes a ton of sense.
So because this has been going on for some time, I was just afraid that making it so specific to the goal of testing, we might do throwaway work.
I think we'll agree. The problem's there. We just solve the problem. This is not this. Incubate it and incubate a solution.
And there's nothing here that prevents you from actually using it in production if you want to. The parameters are controlled in deployment, and they're going to be enabled for testing. If there's a production deployment environment that you control, theoretically you could enable it. We wouldn't do so by default, just out of caution, until we're comfortable that this is something that is working the way we expect. But it won't be blocked out. There won't be throwaway work.
So
We're good.
Right, so I just want to, what's the outcome here? What outcome were you wanting? Did you get?
I wanted to make sure that nobody needs changes in control manager, and it seems nobody does. And that's it. And now it's my fight with SIG nodes to make it happen.
We're good with step one. This is great.